Yes? Okay, so how do we do the very first one? What? Yes, you want to get 0 on one end because you will attempt to solve this by factoring. And in order to solve by factoring, it's essential that one side is 0. So now you're going to try to factor that, right? So how would you factor x squared minus x minus 12? Right, x plus 3, x minus 4. The product is negative 12. The sum is negative 1. So you add, you set both of these to 0 now because it's a product, right? So what are the solutions? You should have. See, you cannot take the square root if the other side still has x's in it. In this case, you can, because all the variables are under the square root. But there, the only way you can know how to solve this right now is by factoring. And in order to solve this by factoring, one side has to be 0. How about the next one? It's already factored. Yeah. Set each factor to 0. So what's the first one? 0. The next one? 1/2. And the next one? Negative 5. All right, good. Now this one, all the variables inside the square. The other side is some number. So what should we do? Yeah, take the square root of both sides. What do I need to remember? Plus or minus 2. So that's two equations. X plus 1 equals 2. X plus 1 equals negative 2. Right? So x equals 1. X equals negative 3. Yeah, you can square, combine like terms, factor, set it to 0. It will work. It's quicker this way. If it's already in this form, we like that form. Okay, so this is what we called last time extracting the square root. So again, what that means, if you have all your variables inside the square equals some constant, then whatever's inside the square is plus or minus square root of that constant. And then we can start solving for x. Right? So this is good. This is a good news. When your equation looks like that, you're supposed to jump up and down and scream yeehaw, because that's good. Because you don't have to factor, you just take the square root and it gives you plus or minus. Okay? So this is good. This makes us happy. Where's our happy place? Here we go. This makes us happy. Because if again, the equation like we just did, the first one, it's still okay. We can factor that. It's pretty nice, right? But what if this was not 12, but what if the equation was 11 equals? Okay. Can I factor that? No. So factoring is not going to work. Can I do the good thing? Because I have that extra x floating around, right? So none of our techniques work right now, but I still would like to solve this equation for whatever reason. So we're going to talk about how we can actually turn this equation into something like that. Because if we actually manipulate it algebraically so it looks like all our variables are inside the square and the other side is a constant, then I can just kill the square plus or minus and then solve for x. I might get some really nasty numbers with square roots and all that junk, but I should still be able to do that. So now I'm going to play a little game with you. Let's say this is what I'm looking at. I have an x squared and then some number times x. Okay? So I'm going to go all the way back to the first week when we started learning some of those fancy formulas and things like that. And when we were deriving a square of a sum formula, at some point I was drawing some squares, and remember that? I was doing little geometry. Because if you remember, x squared, geometrically speaking, is an area of a square with the length of which side is x, right? While just the product of two numbers is an area of a rectangle where one side is x and the other side is d, right? So this is dx. Is that right? Well, now, if you remember the way we were playing this game before, I'm going to cut. That looks like cutting. I'm going to cut this rectangle in half. Okay? So if I cut this rectangle in half, I'm going to put one half over here of that rectangle and the other half of that rectangle over there. Now again, this side is x, this side is x. What is that side? Well, yeah, half d, right? D over 2. And what is this side? D over 2. Do you agree with that? How would you describe that shape? This shape right here. What is this? Does that shape have has a word, has a name? Do you know a shape like that? No, neither do I. It's a combination of rectangles and squares. But what if I wanted to turn this shape into a square? What is missing to make that shape into a perfect square? That little corner, right? What is this corner? If I were to add this corner, what is that? It's d over 2, d over 2, so it's d over 2 squared, right? So in order for me to make this expression, x squared plus some number x, into a perfect square, I need to add half of d squared to it. That's what this little geometry tells me. If I add half of d squared, then all of a sudden that whole thing becomes a perfect square, right? The side of this square is x plus d over 2, x plus d over 2, so it's x plus d over 2 squared. What I just described, we call this, as we see it, it's called completing the square. And it allows us to find that missing little piece that we need to add in order to make our picture into a perfect square. Right? Isn't that cute? Yeah, whatever. So now let me just give you a few examples. So let's say if I give you this problem, again, we're not solving any equations yet, but if I start with something like this, x squared plus 2x, whatever it is we did, this thing right here. Sorry for moving all that stuff around. Here we go. So if I start with x squared plus 2x, so this is what I'm starting with. What do I need to add to that expression in order to make it into a perfect square? Right, so I'm going to take whatever the constant in front of x, which is 2. This tells me divided by 2, so it's 2 over 2. Then I'm going to square it. So what is 2 over 2 squared? Just 1. So I have to add 1 to make it into a perfect square, because now it fits our favorite formula. It becomes x plus 1 squared, right? That's it. If I give you this, if I start you with something like that, what do I have to add? What is it missing from being a perfect square? 10 over 2 squared. So what is that? 25, right? 5 squared. And that is a perfect square trinomial, right? So all we're doing, first of all, we have to realize that there is nothing in front of x squared, right? All our rule says, okay, you just have an x squared without a constant. So we take the coefficient in front of x, we half it, and we square it. And that will give me that missing corner. That 25 would be that little corner right here. That's what 25 is in that example. Okay? So this is x squared, 5x, 5x, and then 25. Gave you a perfect square. But anyways, all you have to do is take the number in front of x, divide it by 2, and square that. That gives me that missing piece. Is that okay? What if I start with something a little uglier? Yeah, so really what 2 comes from, that's your, if you just think about that square of a sum formula, it's 2ab, right? So your middle is always that double product. So dividing by 2 tells you what the other number is. Or another way to see that, because we came up with that in our formula. So whatever the number in the middle, which is 3, we're going to half it and square it. So I'm actually going to add 9/4. That's what's missing. Even if it's an odd number, divided by 2 and square that, this whole thing becomes x plus 3/2 squared. It's an ugly perfect square. Well, what is 3/2 squared? Right? So x squared minus 5/7 x. What do I need to add in order to make this into a perfect square? So divide that by 2, right? Yeah. What is 5/7 divided by 2? Yeah, times 1/2, right. So whoever said 5/14, you're exactly right. So 5/14 squared. That's what's missing. So you take the number in the middle. I actually can write it 5/14 squared. I don't have to write it as 25/196 probably. So this is going to be x minus 5/14 squared. So whatever the number you're squaring here ends up in the parenthesis. This is your b squared in the formula. A minus 2ab, a squared minus 2ab plus b squared is a minus b squared. So that's all we're doing. If there is no coefficient in front of x squared, we're just going to take the number in front of x, divide it by 2, and square that. So that's what's missing in that trinomial to make it into a perfect square. Okay? So does that make sense, how you find that missing corner? Whatever's in front of x, half it and square it. Okay, so now let's use it to solve equations. So we call this is our third technique, solving by completing the square. So I'm going to start with this example. Because if you're giving a problem like that, and I'm just asking you to solve this, your first urge should be to try and factor that thing. And if you try, it won't work. Because you want two numbers that multiply to -6 and add to +2. That doesn't work, right? Even if you try really hard. So factoring doesn't work. That extracting the square root doesn't work because I have an extra x floating around. So what I'm going to try to complete the square, make it so I can use the extracting the square root. So here, I'm only going to focus on these two terms. I'm going to try to complete the square for where the x's are. So that -6, it's really, it doesn't help me to complete the square, so I'm going to kick it out. So first I'm going to get rid of that constant. I'm going to write it as x squared plus 2x equals 6. So whatever that constant is, I moved it to the other side. Okay? So now let's see what this thing is missing. How do we find the missing corner, that missing piece? So we're going to take 2 divided by 2 and square that. So I really have to add 1 to make it into a perfect square. Do you all understand where that 1 came from? Well, now we're dealing with an equation. So if I add 1 to the left side of the equation, I have to add 1 to the other side. So plus 1. To keep that equation balanced, right? If I decided to add something to one side, I have to add the same thing to the other side. Well, now look what happens. The left side now is a perfect square. The left-hand side factors into x plus 1 squared, right? What about the other side? What is the other side? 7. So now I put my equation into that form that makes us happy. Remember the smiley face, that form? Because now I have a perfect square equals some number. So how do you proceed from here? So I'm just going to do the extracting the square root thing. Take the square root, you end up with x plus 1 equals plus or minus square root of 7. And solve for x. X equals -1 plus or minus square root of 7. You can actually leave your answer like that. There's nothing much you can do. That means you have two solutions, -1 plus square root of 7 and -1 minus the square root of 7. So again, the goal was to get to this point. This was the moneymaker right here. So we can take the square root. In order to get to that point, we had to complete the square just on the variable component. So we looked at that, realized that we needed a 1, so we added 1 to both sides. Well, because we wanted to turn that into that. Okay, so that's what we were talking about here. Because I want to make it like that. I want to turn it into this form. Because I want to pack all my variables inside the square. Because that x right there is messing with me. That x prevents me from doing anything with that equation. I have to shove that x inside the parenthesis. So this way I can kill that square so I can solve it. Now in order for me to shove that x inside that parenthesis, I had to complete the square. Literally, that's, remember the picture? We're looking for that missing corner. So that 1 is that missing corner. We'll find that missing corner by taking the number in front of 2, halving it, and squaring it. So that's the 1. but we had to add 1 to both sides to keep the equation balanced. Well, maybe a few more. Let's try this one. X squared minus 6x minus 11 equals 0. Again, the urge is to try and factor, and if you try and factor that, it won't work. You cannot get two numbers to multiply to negative 11 and add to negative 6, right? That just doesn't work. So again, we're going to have to complete the square. So the first thing that we did in the last example, we just focus on the terms that contain a variable, and we ignore the constant. The constant will play out later. So first, get rid of that constant. And now complete the square. So if you're looking at x squared minus 6x, what is missing? 9. How do you get that 9? Yes, 6 over 2 squared. So whatever the constant, divided by 2 and square that. So that's plus 9. If you add 9 to one side of the equation, you have to add 9 to the other side of the equation. That's right. So the left side is x minus 3 squared, while the right side is 20. And now it's in the form that we like, that we can just go ahead and take the square root of both sides. So again, when you face with a situation where there is no coefficient in front of the x squared, just take the number that's in front of x, divide it by 2 and square that. That gives you that corner, that missing piece that allows you to complete the square. So this is the hard part. Getting to this point is the hard part. From there, you just take the square root, do the plus or minus, and then solve for x. Because if you take the square root of both sides, that's x minus 3 equals plus or minus square root of 20. Right? Now I can simplify the square root of 20. 20 is 4 times 5. So that becomes 2 square roots of 5. And add 3. So here we go. These are the solutions to that equation. Order of operation, I have to first multiply by the root of 5. So there's nothing I can do with that.
So you have the x minus 3 and then 5 is x equals 3. Is that?
Yeah, so just, because I still have to solve for x, so add 3 to the other side. So I have two solutions. 3 plus 2 square roots of 5, that's one solution. The other one is 3 minus 2 square roots of 5. So you can list them like that, no reason to write them twice. But again, you see the process first, get rid of the constant, then add what's missing to complete the square, then write it as a perfect square, and then extract the square root. So that gives you the technique we learned last week. When you get to that point, then that's the question from your quiz. Right? But you have to get to this point, and we do that by completing the square, finding that missing piece. How's that? These are good problems, by the way. These are easy ones. The ones that don't have a number in front of x squared, because of course there's no reason to, not have a, what am I trying to say? Because clearly I can put a number in front of x squared, and then that makes it a little messy. But let's just do one more where we don't have a number. Let's throw something like this, like x squared minus 5x plus, I don't know, 1 equals 0. Okay. Again, urge should always be to try and factor. And again, it doesn't work in this case. So that plus 1, we don't care about the plus 1. We're going to move 1 to the other side. So that constant play out later. So now I have to complete the square. So x squared minus 5x. So what is missing? What do I need to add in order to complete the square? I have to do 5 over 2 squared. Whatever that is, right? That's what I'm adding to both sides. 5 over 2 squared, 5 over 2 squared. I mean, I can worry about it later. But that's what I'm adding to both sides. You take the number in the middle, you half it, and you square it. So the left side then automatically becomes x minus whatever that number was, 5 halves squared. That's our left side now. And that's the whole purpose of doing that. So you can pack all the variables inside that square. Because the other side is just a constant, negative 1 plus 25 over 4. That's what that is. Right? And if you actually do that, if you actually perform this computation, negative 1 plus 25 over 4, what does that equal to? Right, 21 over 4. You do the common denominator, so it's negative 4 over 4, right? So 25 minus 4 is 21. Here we go. So, which part? Well, you just 25 over 4 minus 1. So this is 25 over 4 minus 4 over 4. So it's 25 minus 4 over 4. So it's 21 over 4. So again, the hard part was to get to this point right here. So questions, how we got to this point. Because the rest is just taking the square root and solving for x. The rest is the easy part. But how we got to that point, that's the important and the hardest part here. Do you see what we did? No, the final answer should be x equals something. So we're solving for x. This is a halfway through point. But yeah, but we're done with the harder part. But so the question is how we get to the harder part. Moved 1 over, took the number in the middle, divided by 2, square that, added to both sides. So that's where that comes from. 5 over 2 squared, you add that to both sides. So the left side now is a perfect square. Left side equals that. While on the right, we had to, actually combine those numbers to get 21 over 4. So what do we do now? Square root both sides, because you still have to solve for x. So x minus 5 halves equals plus or minus the square root of 21 over 4. Right? The square root of 21 is square root of 21, but I can do the square root of 4. So it's plus or minus square root of 21 over 2. That's the other side. Right? And now finally, how do you solve for x? What? Yeah, so add 5 halves to both sides. So x equals 5 halves plus or minus the square root of 21 over 2. Same denominator, so you can actually combine that. X equals 5 plus or minus the square root of 21 over 2, like that. That means two solutions. 5 plus square root of 21 over 2, whatever that equals to, and 5 minus the square root of 21 over 2, whatever that equals to. So these two nasty numbers solve that equation. Okay? So we clearly cannot do that by factoring. Remember how you do factoring? You look for two numbers that multiply to 1 and add to -5, right? Well, these are these two numbers. They multiply to 1 and add to -5. I mean, these are nasty. Only with the opposite sign. So it's x minus that number. Okay, so again, what did we do? We looked at the problem, get rid of the constant, halve the middle, have the constant here, square it, add it to both sides, so you got yourself a perfect square on the left, automatically. That's why we're adding this ugly number, so it comes out like that. Okay? The right side we had to combine into a single number, got us 21/4, and then you take the square root of both sides, plus or minus, and then solve for x. Fun? No? Well, let's make it fun. Let's put a number in front of x squared. Okay. So the way I like to start this problem is, again, I have that constant, -5, which I don't care about. I'm going to get rid of that -5. Just like before, we're going to get rid of those constants. So this is 3x squared minus 4x equals 5. Okay. So everything that we've done up to this point, with me drawing rectangles and squares and playing with completing the square, we never had a coefficient in front of the square. Now we do have a coefficient in front of the square. If I did not have that 3, that problem would be no different than what we've done before. So let's get rid of that 3. How would you get rid of the 3 that multiplies x squared? Yeah, so just divide both sides by 3. Get rid of that constant. So divide by 3, x squared. Divide by 3, -4/3 x equals 5/3. So that's where we're at. Divide everything by 3 to get rid of that coefficient. Okay. Now we can complete the square. Yeah. So you're going to do 4/3, and you divide it by 2. So what is 4/3 divided by 2? Yeah, 2/3. If I had 4, if I call this a third, here we go. Here's a lesson in fractions. This is literally 4/3. If I call that a third, that's a third. So 4/3, what's half of it? 2/3, right? That's how fractions work. Now I need to put them all back in the same. Okay, so yeah, so that's 2/3 squared. So I'm going to add 2/3 squared to both sides. So that's that missing corner in that picture. So the left side is a perfect square, x minus 2/3 squared. That's the left side. While on the right, I have to add those two fractions. So let's try that. Let's see what's on the right. So that's 5/3 plus 4/9, right? That's what I need to compute. What is 5/3 plus 4/9? How do I do that? Yeah, so times 3/3. Yeah, so that becomes 15/9 plus 4/9, so 19/9. That's the constant on the right. So this is where we're at. X minus 2/3 squared equals 19/9. Okay? So this was the hard part, to get to this point. This is the new stuff from today. The rest is just taking the square root. So again, look back and see what we've done up to this point. As before, get rid of the constant. New step was to divide by the coefficient in front of the square so we can complete the square. So when you get rid of that coefficient, go ahead and complete the square by taking the number in front of x, dividing it by 2 and squaring that, add it to both sides of the equation. Right? So the left-hand side is a perfect square. The right-hand side, add those numbers. You got 19 nines. So now, to solve, take the square root. Right? Nothing I can do about square root of 19, but I can do square root of 9. So this becomes x minus 2/3 equals plus or minus square root of 19 over 3. The square root of 9 is 3. Right? And finally, to finish this problem, add 2/3 to both sides. Common denominator. So it's 2 plus or minus square root of 19 over 3. Yeah? It's fun. Solving equations by completing the square. And this is one of the worst scenarios, is when you have a number in front of the x squared, gives you a fraction in the middle. So this is probably as bad as they get. Okay? Well, of course, they can get a little worse if you end up with something negative under the square root, then it'll just have no solutions. Okay? But now, sure I would. That's actually easy. You're like, oh, a negative under the square root, I'm done. Nothing else to do there. This one, I have another example. It came out a little nastier. Maybe this would be the worst case scenario. 2x squared plus 8x plus 3 equals 0. So now you're going to help me. And on this side, I'll outline the steps. Steps, solving, by completing the square. So what's the first thing you want to do? Yeah, so move the constant to the other side, right? That's what you guys said? Is that what you said? Yeah, I thought so, right? Get rid of the 3. So subtract the constant from both sides. So that's our first step, was 2x squared plus 8x equals negative 3. So only x is on the left. What's the second thing that you want to do in this case? Right, very good. Get rid of the coefficient in front of the square term. So divide both sides by the coefficient in front of the square. So the second step, divide both sides by 2, gives us x squared plus 4x equals negative 3/2. What now? So complete the square, right? Add the missing piece. All right, so the third step is to complete the square by adding the missing piece to both sides. So I'm not going to go into all the details because we've gone over the completing the square, but yeah, we're going to take the number in front of x, we're going to half it, and we're going to square it. That's what we're adding to both sides. So we're going plus 4 on both sides of this equation, right? Right? We're taking number in front of x, which is 4. We're going to divide it by 2. So 4 over 2 is 2. Then you're going to square that. So that's back to 4. So we're adding 4 to both sides. So that gives us x plus 2 squared on the left, right? Because that's your formula. Yeah. While I'm sorry, on the left, x plus 2 squared. On the right, 4 minus 1.5 is what? 4 minus 3 halves is 5 halves. Now, I'm not going to do the dirty work. You figure that one out. Is that 5 halves? Okay. Yeah, so then finish by extracting the square root. So now solve. So solve this equation by extracting the square root. So this gives me x plus 2 equals plus or minus the square root of 5 halves. Right? Well, there is a little issue with that. Because every problem we've done before, when we took the square root, we were able to take the square root of the denominator. 9 turned into 3. 4 turned into 2. Right? But here, I have a square root of 5 over square root of 2. Remember how it's politically incorrect to have an answer that has a radical in the denominator. So I have to rationalize this. Well, yeah. But that's not that bad, right? What I need to just multiply by root 2 over root 2, right? That's all I have to do. Because I don't like having a square root in the denominator. So this is x plus 2 equals plus or minus the square root of 10 over 2. I have to rationalize my denominators. Cannot leave the answer with the square root in the denominator. So solve for x. X equals negative 2 plus or minus root 10 over 2. That's the answer. We'll have to rationalize. Before that, we lucked out. We always ended up with the perfect square. The reason why that happened here, because you see, before, we had those fractions in the middle that we could not reduce. But here, we were able to reduce. 8 over 2 is 4. If I actually kept it as 8 over 2, and instead of adding 4 to both sides, I added, what? 8 over 2, so it's 4 over 2. So if I added 16 over 4 to both sides, then it would come out pretty. But that's silly to not reduce your fractions. So you have options. Don't reduce your fractions, and then you don't have to rationalize the denominator. Or reduce your fractions, and then just do a quick rationalization in the end. Well, because I have a square root there, right? It's square root of 2. Because this is square root of 5 over square root of 2. That's politically incorrect. We cannot have an answer with a radical in the denominator. So you always have to rationalize that. Okay. So this is solving equations by completing the square. Isn't that nice? So that's an important technique, the whole idea of completing the square. in college algebra, we bumped into completing the square in 4 different places. When you have x squares and x's floating around and you want to pack them into a single square term, you have to do that. Not necessarily when solving equations, but just playing with some expressions. So the good news is if I just give you an equation like that and I tell you solve it, and I don't tell you how to solve it, there is another way of solving these equations. And you're probably going to be using that if given options. If I tell you on the test, solve this equation by completing the square, that's probably the only time you're going to use solving equations by completing the square, unless you ask specifically to do that. Because there is another way of solving that equation. Some of you might know that. So there is another technique. By the way, we've been solving equations, what we've done today, mostly equations of this form, where a is not 0. These are called quadratic equations. That's what we've kind of gone through so far. And we know that sometimes you can solve it by factoring. That was that first question on your quiz, when things factor nicely. We can do the extracting the square root if it's already in a perfect square mode. What we learned today is completing the square. That's another technique for solving the quadratic equation. But then there's a fourth technique. And since most of you have a high school diploma, you've seen that technique, right? What am I hinting at? Quadratic? Well, that's what we're trying to solve, quadratic equation. But what you're thinking about is quadratic formula. Quadratic formula. Yeah, that's an awesome formula. There are songs that have been written to serenade that formula. Who remembers that formula? Do you remember that formula? Well, you can sing a song, but I really need a formula out of you. Remember the formula? Negative b plus or minus the square root b squared minus 4ac all over 2a. So that's in relationship. This in relationship to this equation. So you identify the a, b, and c, the coefficients in the equation, you plug them into that formula. You've seen that before, right? Yeah, you have. Oh, yeah. So let me show you how that works really fast. Let me take this equation we just did, 2x squared plus 8x plus 3. Yeah, 2x squared plus 8x plus 3 equals 0. What is a in this equation? 2. So whatever's in front of x squared, that's a. What is b? 8. What is c? 3. I'm sorry, this is b, this is c. So all I have to do is to plug in a, b's, and c's into this formula. See how that works? The formula tells me take whatever the b is, put a negative in front of it. So b here was 8. So then I'm going to end up with negative 8. Negative b. Plus or minus the square root b squared. Right? It says b squared. So 8 squared minus 4 times a equals 2 in this case, times c equals 3 in this case, all over 2a, so 2 times 2. So all I did, I just plugged in my a, b's, and c's into this formula. Right? For every a, I put a 2. For every b, I put an 8. For every c, I put a 3. because that's what my equation told me to do, right? Now if I actually go ahead and compute that, this is negative 8 plus or minus the square root of 64 minus 8 times 2 times 3. What is that? 24 over 4. Is that right? 64 minus 24 is how many? 40 plus or minus 40. Is 40 a perfect square? No. So what's the next best thing? Yeah. 40 is 4 times 10, right? 40 is 4 times 10. So I can take the square root of 4, so it's negative 8 plus or minus 2 square roots of 10 over 4, right? So I can reduce everything by 2. 8, 2, and 4, all multiples of 2. So if I reduce everything by 2, is that coming out to be the same answer? I did something wrong before then. Oh, my shiny, oh no, it's all good. Yeah. So that's what it came out to be, right? So see, all I had to do just to first know that formula, and then plug in the appropriate numbers where they had to go, and simplify it a little bit. Is that the same answer as we got before? That's what we got before. Is that the same? So, I have a negative 2, but it's not divided by anything. There I had negative 4 divided by 2, so that's the same thing, right? Because I can actually say, this is the answer, but if I wanted to make it look the same, so if I divide by 2, so it's the same as what we got before, right? So it works. The quadratic formula works every time. It's easier to use than completing the square, by the way. So you need to know this formula. That's a must know. Okay? You don't get to go to college algebra if you don't know that formula. You can Google the songs. There are songs that somehow supposed to help you memorize that. I don't know. Would you like to perform one for us? Is that what you? Now, don't write this down, but help me. You're going to tell me what to do now. So here's an equation, ax squared plus bx plus c equals 0. I'm going to go ahead and solve that equation by completing the square. So that's what I want to do now. And I'll do it myself. You tell me what to do. What's the first step in my solving equations by completing the square? All right, so the first thing, subtract c from both sides. What's the second step in me completing the square on this? Good. Divide both sides by a. So that gives me x squared plus b over ax equals negative c over a. Right? Right. So then take b over a times it 1/2 and square. So that's really b over 2a squared. Right? Yeah. So I'm going to add that to both sides. Is that right? So then the left side now is x squared plus b over 2a quantity squared. Right? That's the left side. By whatever we just did. Now on the right, I have to do some work. So it's b b over 2a squared, that's b squared over 4a squared, right? Minus c over a. So in order for me to subtract these two fractions, I have to find the least common denominator, which is what? Squared. 4a squared. So the first fraction is happy. What do I need to multiply the second fraction by? 4a over 4a, right? So look at this. It's, by the way, this shouldn't be squared, sorry. So it's x plus b over 2a squared equals b squared minus 4ac over 4a squared, right? If I actually combine those. Okay, so now I have my perfect square equals some number. So I'm going to go ahead and take the square root of both sides. So this is x plus b over 2a equals plus or minus the square root of b squared minus 4ac over 4a squared. I can take the square root of the denominator, can I? What is the square root of 4a squared? What? 2a. Now, again, technically the absolute value, but the absolute value will just give me plus or minus, and I already have plus or minus, so I don't need to worry about the absolute value. So b squared minus 4ac over 2a, right? And finally, solve for x. X equals negative b over 2a plus or minus the square root of b squared minus 4ac over 2a. Right? Same denominator, combine negative b plus or minus the square root of b squared minus 4ac over 2a. So that's your quadratic formula. Quadratic formula does all the steps of completing the square in one move. Okay, so that's what that formula comes from. So you can either memorize it or you rederive it every time. It's up to you. So yeah, you should know that formula. Okay? Isn't that nice? So when I tell you solve this equation, and you cannot, your first urge is always to factor, and the factoring doesn't work. Or if factoring is messy, sometimes factoring does work, but it's hard to factor. Just go straight for that formula. It will work every time. But if I tell you solve by completing the square, you better solve by completing the square. Okay? All right, so now it's a payback time. You're going to tell the college how wonderful your experience in this class was. Have you done those before? What? Yeah, you're going to tell it's about this class. So I'm going to need a volunteer to take those to an office, which is on this floor, the last office on the left, if you go that way. Right before you exit the office on the left, Elise Tanner, give it to her. Want to do that? All right, so you're in charge then. Yes. Let's see. So you can pass this around. If you've done them before, you know how that works. If you haven't done those before, I don't get to see that for a long, long time. So definitely when your grades are in and all that stuff. So I won't remember. Actually, I should probably stop recording. Actually, don't do anything.